What was I saying? Yes, so reload button, you hold it down and force it to reload. I imagine on this lovely page with this adorable kitten, if you make your first request, you have a bunch of requests that have happened. And you can see that they will come back with a 200 response and a bunch of information about how big of the sort of response data is, how many bits of information. Now, if I refresh the page again, you'll see that some of the responses have changed. The response status code is saying that because I've already made the request and nothing's changed in the meanwhile, I don't need to get back that data. I go to 304 and I have the request gets sent, but just the response comes back with the 304 saying that no worries and nothing's changed, and my browser then loads this from its internal cache. Now, there's a slight difference here with this request, that it doesn't actually make the request to the first page and just dives into the memory cache of the browser and serves it from there. So there's no actual request that gets made from this one, but for the other two, they do make a request. They just say that it's not modified, and it still actually loads it from its memory. So this is a way for your browser to sort of try and be clever about not making like redundant requests. Sometimes this happens a lot. So sometimes browsers just make a ton of requests repeatedly, and it just saves time and sort of computational resource. So usually don't really worry about it. This doesn't really happen a lot. We won't have to do this ourselves, but sometimes this happens. It's just a feature of modern browsers in the way that they want you to have to always make the same request over and over again and always getting that data when you already have it. So in order to force that sort of first occurrence, just hold that reload button down, empty the browser cache for that specific URL, and you are good to go. What is the externally requested image return status code? But the local return 304. I'm actually not exactly sure what governs the behavior of saying not actually make the request with the external requested resource compared to the internal one, but I imagine it's because of that. I imagine it's exactly because it's from the same host, so we don't have to make any external requests. The browser's making the request, but I'll have to sort of double check that, but I imagine it's because of that. Cool. Why does the local image not save to browser cache? It does. So after that first request, it's not modified, so there's no data that comes back in the response, and you serve it from the local cache. All right. Again, we don't really have to worry about this because I only want you really to pay attention to this first example with the real request and response. All right. And the particulars of how the redirecting the server from local cache, we don't have to worry about, but it does. After that first request, we get back the 304. We don't get that response data back. We serve it from the local cache. Why does it take the local image longer to load than the browser image? It's an interesting question. Okay, so what we're saying here is the time it takes. This resource here is stored within the same domain. All right, so we don't need to go external to the DFA cats.com domain to get any further resource. Like this one, we do. We have to make an external request and go to a different domain a cross-origin request to get this data. Now, this request, even though it's internal, it's still a GET request. We're still making an HTTP request to get it. But the question is, why is this slower, about 2 times as slow, given that it's a smaller size and it's within the same domain as opposed to this external request? That's about 3 to 4 times bigger, but it comes back in about half the time. So there's a bunch of things that govern the time of a request. You can see here that the biggest time sink for this request is waiting for that first byte. Time to first byte is TBFB, for that to come back. And this will be a factor of the resources of the server that is going to send you back some data. So the server that is running here on Heroku app is a small one. It doesn't need that much a resource because all it's doing is serving some static content, a few things, whereas the server I imagine for redbubble.net has a bunch more resource available to handle requests and responses, right? So this comes down to a bunch of things for the resources available for a server, for it to be able to handle multiple requests at one time, and a bunch of things like that. There's a few more things that go into balancing the load for a website, and how do we handle like 1,000 or 1,000,000 requests at one time, like what happens in those situations, how much resources available to do those things. But we can ignore all of that and not worry about it. And the main way to answer this question in terms of why does it take longer and why do some things take slower is simply about the resources available for a specific server, all right, and clearly the size. But this one is governed mostly, the difference between these two is mostly the resource available to the server. Interesting question. I can't see anyone's faces. If you want to follow up on any questions, please just verbalize them, all right? Okay. How do we model the inline requests to external pages? Also, do they come from a browser? Yes, they do. When we make the request to /cats, we get back this data, this text, all right, in the response. A browser then renders these 2 lines. And once it gets to line 1, it sees it's an image element with an attribute value pair, source, and this, and immediately it makes this request. That's why you see this request happen first, and then this one then executes. So they both happen. We make this request. It's an external request. We don't provide it any alt, and then this one then executes. So how do we inline? Also, they come from browser. Yes, they do come from a browser. So the browser executes those requests, it waits for those responses, and then displays them on the page. And the way you can model them is, did anyone do it? Other server. Can't really read this. Host Heroku CDN get, but you can add another actor here. So in the same way that this person's done, you can add in another actor with a line to it and say, once we get back the response, then the browser executes another request and gets back that data, and then we show it to the user. All right, so something like this would be appropriate in the way that we can model it. Did anyone else have a look at this? Not quite in the same way, this person. I like the screenshot of the cat here. I think this one is the one that I currently like the most, in the way that it has this other action that we model it in the same way that the order of these things are happening. This is wrong URL, but maybe that's not quite the correct. User clicks, click for cats. We go to cats, we 200 or 304, fine. We render the HTML, and then at this point here, I would probably wouldn't put this arrow just yet. We would get that data to the browser, we'd get make a few requests to the other server, get back this information, and then show it on the page. And these two things are happening. Yeah. Cool. It's not as if they show what there's like a separate, three separate processes here. They make the browser sees it, and before it gets to the next line, it executes that request. All right. So this render is actually quite a complicated process. The process of creating the HTML structure, and then the browser paints the screen about 60 frames per second to update anything that's happening. But HTML is sort of passed line by line and then understood, make any requests needed to go get external resources, and then it shows up on the page. So how do we inline the model? The model. How do we model the inline requests to external pages? You can just add them as a separate actor and understand the order in which those things are happening, and they do come from your browser. The name of the server is just simply whoever organized or arranged the code for the server that's being used as like a software package, and sometimes gives it a name. So that's fine. Cool. Okay. Any follow-up questions on these ones here? Now, where is everyone's basis? I can't see anyone. Okay. I can see everyone again. Yay. Any follow-up questions?
So you just do the render HTML at the end instead of doing render HTML, render JPEG, render JPEG. It would all just be render HTML at the bottom of that bottom one. Instead of having render HTML, render JPEG, you just have one rendered HTML at the bottom.
Pretty much. It's always a little bit too complicated to show that the browser is painting the screen at 60 frames per second. So any update that happens, it gets immediately shown. The important thing is that HTML is passed line by line, so it executes its request straight away, and then it's shown back to the user. So the way that we would model this is as soon as we get back that first response that shows the HTML, then those requests happen immediately, and then we get back the HTML that the user sees.
Okay. So it's like we don't know what order that's going to happen because is that asynchronous, or does it wait for that JPEG to come back and then go look for the next line? Or
it's asynchronous in the way that it will execute and then move on to the next line. So sometimes you'll get pictures that will take longer to load as a result.
So yeah, the third picture could come back before the second picture.
Yeah.
Cool. Thanks.
The requests are made in order, but depending on the speed of the server, it doesn't wait for that first image to come back. It will keep moving through the lines of HTML, having executed those requests in order, and then the browser gets repainted when that data comes back.
Okay, cool. Thanks.
Okay, a couple more important things. Most of all this are like some particulars. Again, definitely feel free to be curious and explore and use this tab to have a look at what's going on. And I really do encourage it. You get a lot of information here about things that are happening, but also the more important thing is making sure you understand the request that gets made that has a URL, an HTTP method, and this is the more important parts of the request. And then in the response, we get back status code and then any response data that we can have a look at. These are still GET requests that gets made to fetch resources, regardless of whether they are external or internal. This is still just a file in a directory that we make a request to. So we can make requests to specific files as a GET request. We can get resources, or we can make a request to a path, and then our application can handle it. All right. The other thing is looking at that difference between a GET and a POST request. So as some of you might have seen, when look at these previous comments. What did you think? Funny. If I make this GET request, this is a form. So forms by default as a part of their behavior as an HTML element. When you submit them by clicking on the submit button, it executes a request. So if I click on this get form submit button, I can see here this is the request that gets made. And notice that in a GET request, form data is actually added as a query string. All right, we notice the query string with this question mark. And let's have a look at the form of this request. So let's go back down to the request. And we can see here that this is the request that gets made. It's a GET request to /thanks with a query string of comment equals funny. A comment, where does this come from? Well, this is the key, and this is the value. Funny is what we wrote. Where does comment come from? Well, if you have a look here in the HTML, the form for get has a name attribute for this input field. And this is where it gets the comment from, right? So this gets formed as the key, and then funny is the value. And this is how the request gets sent. So if I execute it again, let's have a look at it. So you can see here that the request is /thanks. That's where we send it to. And then comment equals funny is the query string. As a GET request, it gets passed in the request as part of the query string. All right. This is the path. Question mark denotes the query string, and query strings are always a combination of key value pairs. All right, separated with an and sign, so you can have multiple key value pairs. If we have funny and glorious, if I make this as a request and have a look at it, you can see that the spaces are encoded as a plus sign. If I include other characters, you can see that the encoding doesn't always match up to what you expect. All right, so this is why, for example, in the simple demonstration I did yesterday, building that simple application how to get and a post request, we have to pass the request body. All right, anything that comes over on the request, we have to be able to extract it, and we have to pass this back into something that we understand. So there's a bit of code that helps us with that. So there's some encoding and decoding that we have to do. So this is a GET request. GET requests appear like this. If we go back to have a look at the POST request, let's say it's not funny, and make this post request. You can see in this request, it looks slightly different. We just post slash to slash thanks. Now, where is the data? Did anyone manage to find out where this data is that we just sent across when they were modeling it? So if you scroll down to the bottom of your DevTools, you'll actually see one extra little area here called form data. So when you post, make a post request using your form, it gets added to form data. And so you have access to form data, and you can have a look at how it comes across like this. This is a set of key value pairs. Comment on the left-hand side, and the value is the unencoded form, not funny. All right. So whenever you're looking at post requests and wanting to see what data is in your sort of inspector, just have a look at the form data at the bottom, and you can have a look at how it's what the raw format looks like. Cool. Those are the two main differences between a GET and a POST request. When you post data, it gets added to the request body or as form data, whereas in a GET request, it gets added as a query string. All right, two different places where that data is kept in the request. What else did I want to have a look at with everyone? I think that's about it. Okay, any other follow-up questions? Otherwise, let's wrap for this morning. Any other follow-up questions? Cool. Okay. What I'd love to note before everyone leaves is just add, I'm going to expand this section because I want to know what everyone's key takeaway from this session is. All right. What do you think has been the most useful? What is the thing that you're taking away? So just add a post-it note in this expand section. Oh, that's not what I wanted to do. Let's lock it. I'll move these out of the way. So just add a post-it note into the section. What do you take away from the session? What did you find most useful? What's here?
4 tips.
All pointing at one single pixel over here. A better understanding of Inspect and what it shows, understood more about how a web page would access an external resource, understood more about how GET and POST requests work with both the browser and server, how to process model requests and responses, understood more about how applications communicate with the browsers and servers, how an entry to a form is transformed into a request, a clearer understanding of data flow between clients and servers, also more familiar with the inspector, understanding how to get more information from the console about what's going on behind the scenes. Cool. Okay. All right, let's wrap there. Thanks for participating in the session. The rest of this morning is back to you. Keep playing, keep exploring, so you can really feel confident in using your developer tools in the inspector to get visibility over network requests, the GET and POST requests that we're making, because it will be important for you to keep getting visibility over the next few weeks. Then we have lunchtime. I will release more peer groups, our new peer groups, just before 2 o'clock. So you'll have access to those. Then we'll gather together to run through the sort of summaries. And then we have Sam going to come talk to us about presence and presentation skills in preparation for the video recordings that you're going to need to make this week or next week. So it's going to be an important session at 2:30. All right. Sound good? Cool. Thanks, folks, and see you a little bit later.